Well, on scatter plots, the scatter plot is basically what it sounds like. It's you plot a bunch of values of data onto an XY plane, and you kind of compare what's going on. And the idea of the whole linear regression is see is there a line that you can make of it. So here's an example of a scatter plot where we have the student's age and their exam score, final exam score, and shown on the graph. And the question is there some kind of relationship between age and score? So for example 1, the table below here shows the number of cricket chirps in 15 seconds for several different air temperatures in degrees Fahrenheit. Plot this data and determine whether the data appears to be linearly related. Okay, so open Desmos.com, and a couple things I want to do to begin with, and I need to kind of switch between the two of these quite a bit to get this set up. First, I'm looking at our chirps. The low value looks like 18.5, and the high value is 44. So that's our x-axis. So I'm going to be looking at changing going to settings here and changing the x values to where the smallest, I'll make it like -5, and the biggest make it 50. Okay, so you'll see that in a second. The y values though, again, I'll say the smallest is -5, just so we have some kind of a boundary there. We can see on the grid what's going on. The highest value looks to be 80.5, so I'll just do like 85. And this will give us a grid that, as you see here, and this is what falls, let me close that, falls within the the screen that's being captured. The next is I want to do a table. So I'll come over here and hit the plus button, and I know it cuts off there, but you see table as an option. So I'm going to fill in the table. And it's really not hard to fill this in. It's really helpful to have the table in front of you. And right now I just cover that screen. So let me try to pull it up on a second screen. Hang on a second. Okay, so I have it on the other screen for the moment. And when it was 44 chirps, that corresponded to 80.5 degrees. And then when it is 35 chirps, that would be 70.5 degrees. And then when we are at 20.4 chirps per minute, we are at 57 degrees. I don't know if you've seen a pattern yet. When it is 33 chirps, it's at 66 degrees Fahrenheit. At 31 chirps, it is 68 degrees Fahrenheit. You see the dots coming in here? This is the scatter plot. And that was 35 and 72. And then we have 18.5 and 52. 37 corresponds to 73.5. And 26 corresponds to 53. Oops, wrong row. 53. Okay, so there's our scatter plot. A lot of the values are up here. Obviously nothing's down here, but I still like to have those down there. And it looks like there is a linear trait to this. So I'm going to keep this in here, and we're going to be doing more with this as we go along. But I'm going to come back to this page. There we go. And so there's the data. And I had already screenshotted this before, but I want to show you how easy it is to use Desmos to get those values. And we're going to be doing a few more calculations. So there's our linear graph. And it says find a linear function that fits the data in the table below by eyeballing a line of best that seems to fit the data. So if I eyeball it, I don't like eyeballing it because I feel like that's such a we have tools. So, but I'll show you the tools in a second. Let me get a straight edge and see what I can come up with. And this is how, before having these nice tools like the regression. Oh, don't do that. I'm trying to put my straight edge up here. I'm going to say that it doesn't like me touching it. Okay, I'm just going to have to do it freehand. Looks like something. Oh, my pencil fell asleep. Okay, it looks like it's something in here. So if I look for places, I don't know, I'm just going to take that. I just say it was going through here. So what would that be? 50 and 20. So let's just say it goes through 20, 50, and pick up another point that looks pretty good. Right up here, that looks like it might be 74 for Y and 40 for X. So 40, 74. If I use those 2 points, just eyeballing it, I would have 74 minus 50 over 40 minus 20 is 24 over 20, which would be, I believe it's 1.2 for our slope. So if we said y minus y1, I'll just do the 2050. So y minus 50 equals 1.2 times x minus 20. So y minus 50 equals 1.2x minus 24. And then we can add 50 to both sides. And y equals 1.2x plus 26. So this is just a guess. I just made that up right here with you. I did not have that pre-planned, but that is the idea of eyeballing it. But we have a much better way of doing that, and that'll be in the next video. So stay tuned.